There was some in first period too that was gone. So, alrighty. So we're going to start looking at complex numbers. And one thing I will say before we get too far into this is that as I've been looking at the quizzes and grading those, the vast majority of the points that are missed on quizzes are not because of a lack of understanding of the big idea, but it's because we're missing details. And obviously arithmetic mistakes happen, losing a negative, that happens, just be careful. But I'm talking about details like you got the zeros of a polynomial, how do you find the max and min points? You know, you average the zeros. And then plug that in to find the max and min point. You know, little details as far as when you're writing down the remainder after you're done with polynomial long division. Make sure you're adding it to the answer. Don't just write it next to it because then it looks like multiplication. So little stuff like that makes a difference. All right, so just be careful, and part of that though is paying good attention here in class and working through examples on your own as we do them on the board. That way you can catch the mistakes that you tend to make and hopefully not make them when you're actually on the test, okay, or on the quiz. So, as we're talking about focusing in class, let's go ahead and get started. Well, we started 3 minutes ago, so. Alright. Complex numbers. Believe it or not, complex numbers are the broadest category of numbers. Ever since your parents started teaching you how to count, alright, you've been dealing with complex numbers. It's just you've been dealing with one specific subset, the real numbers, okay? We have imaginary numbers and real numbers, and all of those fall under the category of complex numbers. Now, when we use this term specifically, typically what we're talking about is a number in this form, like right here, a plus bi, where there is a real portion and an imaginary portion, okay? And this form, a plus bi, is what's known as standard form of a complex number, all right? And you'll see, in fact, in the homework problems, you'll see them ask you to put your answer in standard form. That's what it's talking about, a plus bi. So you can see the real part and see the imaginary part separately. Now, in order for two complex numbers to be equal, the real parts have to be equal and the imaginary parts have to be equal. All right, and that's kind of obvious, but you might use that though in certain problems where we're trying to figure out what certain values would have to be in order to get a specific complex number. You can use that concept there. But before we get into dealing with a plus bi, I want to look specifically at imaginary numbers and make sure that we remember how to work with those. All right, and so first I want to look at what is I, and then how do we interpret different powers of I. So this is a little exercise. It's actually even in your book. But just to remind us, what does I equal? Very good. The square root of -1. And if you remember that, then figuring out the other powers isn't too hard to do, okay? Because think about it. It's saying I squared is -1. Well, when you square a square root, those undo each other. Those are inverses. So you're left with just the radicand, -1. Okay? So that's why I squared equals -1. If you kept going, I cubed. Well, I cubed is the same thing as I squared times I, right? Well, what's I squared?
1.
Negative 1. So, what's negative 1 times I? Negative I. Okay? Then you have I to the 4th. I to the 4th is I squared times I squared. Well, that's negative 1 times negative 1, right? Which is 1. Okay? Now, this is what I like to call a cyclical pattern. It's a cycle, it repeats. Okay? Yes?
Can you go back for like 2 seconds, the other slide?
Okay. This pattern for powers of I repeats. Because we got to 1 when we did I to the 4th, 1 times anything, as we increase to the next power of I, it's going to be 1 times I, right?
Yeah.
So I to the 5th is I. And then I to the 6th would be negative 1. Because it's just an I to the 4th times another I squared. Well, that's 1 times negative 1, which is negative 1. Then you have I to the 7th. That's negative I to the 8th, I to the 9th, I to the 10th, I to the 11th, and I to the 12th. Alright? So you see the pattern. And every time we get to a multiple of 4 on the power of I, we're back to 1. Okay? So this repeating cycle has 4 steps to it, basically. Now, can anyone tell me how would we figure out what I to the 53rd power would be?
Divide by 4.
Divide what by 4?
53.
Okay, good. We divide the 53 by 4, and we goes in once, subtract, we have 13, goes in 3 times, so we subtract, and we get a remainder of 1. So what good was that?
Tells us that it's 1 more.
It's 1 more than
Okay, so this is, the remainder is our exponent of I, so it's just I. Now what does that 13 tell us?
Goes around the cycle 13 times.
Exactly, we go through that cycle 13 times. So if we really wanted to write this all out, you know, we could write I to the 4th times I to the 4th times I to the 4th 13 times, and then we would have this 1 I left over. Okay, there's our 13 I to the 4ths. And then we'd have this I left over at the end. Okay? So, since all of those just equal 1, we can say our answer is just I. So, this cycle repeats and repeats and repeats. So when you're giving an answer and you're dealing with complex numbers, your power of I should never be anything other than 1 in your final answer. If you've got an I squared or an I cubed or I to any other power, you're not done yet. Okay? Always simplify it down so you just have I's. Alright?
All ones
I's are real numbers, yeah.
So the answer is 1?
So the answer is I.
Oh, yeah.
Okay? Yeah, your answer would just be I. Now we'll use that as we move forward, as we do different problems, because we're going to look at adding and subtracting complex numbers. We're going to look at multiplying and dividing complex numbers. and particularly when we multiply and divide, we're going to get these other powers of I, and we'll then need to simplify them, okay? And anytime we're working with complex numbers, our answer will always be a complex number, okay? Yes,
So
sir?
then, like, so the remainder is always the exponent of the I?
Yes, okay? So, for example, if I did I to the 42nd power, well, 42 divided by 4 would be 10 with a remainder of 2, right? So we could say that that's the same as I squared, which is -1. Okay? If we had I to the, let's see, 103rd power, okay? 103 divided by 4 is
25 with a remainder of 3.
good. And that remainder of 3 is now our new exponent, so this is -I. Alright? If we had I to the 28th power, 28 divided by 4 is 7. It came out evenly, so our answer is 1. We have 7 full cycles, so we end at 1.
Do we
Okay.
need to say like I did the cycle 7 times?
No. You just give the final answer.
Thank you.
Alright.
We're gonna have those for the test now.
Maybe not those directly, but
Yeah.
they'll be involved with other problems. For example,
Still harder than that.
okay, let's try these two. Okay, let's try these two first of all. One tip that I will give you is that as you're doing different operations with complex numbers, until you get to your final answer, you can treat this I just like you would any variable. Alright, so, if I were doing this with variables, I would simply distribute the negative, right? And then combine the terms that are alike. Alright, so I'd have my 11 minus 2I minus a -3, so plus 3, minus 6I. Now I can combine the terms that are alike. 11 and 3 is 14. -2I minus 6I is a -8I.
So you factor out too.
If you want to, you can, but you don't have to. In fact, if they ask for your answer in standard form, then don't. Because this is your A plus BI standard form.
So you shouldn't
Okay.
distribute the I.
What do you mean distribute the I?
Obviously not intelligent thing to say.
Okay. So that's all you would do there. Alright. You don't need to factor out anything or anything like that. Okay?
Could you do anything
What? With this one?
like that? Yeah.
What do you guys think? 4I squared minus
I know what you
Oh,
could
so
do,
two
but
IQ.
change anything.
What do you mean, Alex?
You could
You can put it in
change
standard
the
form.
problem.
You can put it in standard form.
Oh, hang on. Shh. What are you talking about? Changing the problem.
Like I could pull out I squared and make it -1, but would that really simplify your answer?
Well, let's think about that. If you factored out an I squared, you would have in the parentheses 4 minus 2I, right?
Yeah.
And you said that's -1, right? So let's throw it back in now. -4 plus 2I.
You live with that
Okay.
standard form.
And that would be standard form. Now, you could also,
Just
right off the bat, I squared is
-1.
-1, so that's a -4. I cubed is
Negative.
-I, so -2 times -I is a plus 2I. You can do it that way as well. Whichever way makes sense to you. Good. Let's try another one here. 6 minus 2i times 2 minus 3i. How do we multiply complex numbers? We FOIL. Again, treat it just like you would a variable until you get to the end. Alright? So if I FOILed this, what would I get?
12 minus 18i minus 4i plus 6i squared
12 minus 18i minus 4i,
plus 6i squared.
good, plus 6i squared. Okay, so here we've done the FOILing, now we need to get our final answer. So at this point, I'm going to substitute in -1 for my I squared. So that's a minus 6. 12 minus 6 is 6. Negative 18i minus 4i is a negative 22i.
We read it that way, right? We can't switch it, like negative 22i plus 6.
That's not wrong, but again, if they ask for standard form, it's always the real part first, then the imaginary part. So just get used to it that way. All right. All right. Let's do one more together, and then we'll look at division. Okay. Someone in third period had a pretty ingenious way of handling this. It wasn't the most straightforward, but it was actually pretty cool. I'll show you when we're done. Okay.
You can just 1 minus 2i plus 1 plus 2i multiplied by 1 minus 2i minus 1 minus 2i.
You actually, that's exactly what the other person said. What would you typically do if you saw this? What would your first inclination be?
You FOIL and then you subtract.
FOIL, FOIL, subtract, right? Let's do it that way first, and then we'll let Maxime say what he was thinking again. All right? So when you FOIL this, what do you get?
1
1 minus
plus 4i. 4i.
Minus 4i. Minus 2i is a minus 4i. And then plus 4i squared. Now we have a minus, and what do we get when we FOIL that?
1 plus 4i plus 4i squared.
Do you guys agree with that?
Yeah.
Alright, good. So now we need to subtract each of these terms as we put them together. Alright, so 1 minus 1 is 0. So that cancels out with that. Negative 4i minus 4i is negative 8i. And then 4i squared minus 4i squared cancels out as well. So our final answer is actually just a minus 8i. Okay? So, just be careful. But notice I'm just treating the I like a variable, and then at the end, if I have an I squared or something, I can plug it in. Okay? Now, Maxime, do you want to come up and show what you were talking about?
Is it? Do I do it?
Okay?
Yes.
Go ahead and finish just to prove that this does actually work.
actually, you know what? Oh yeah, yeah.
You're right.
I think it's two. So,
Excellent. Okay. Now, do you guys know what he did?
No.
Yeah.
You had the same thing. So you want to explain it for us then, Chris?
I think he was much more apt at it. It's a square minus b square.
Yeah.
He
Check this out. He saw it as, like Nick said, a squared minus b squared. And how does that factor into a plus b? Well, actually, Maxime did the minus first. A minus b times a plus b. Okay? So he has the 1 minus 2i minus 1 plus 2i, so minus 1 minus 2i. And then he did the 1 minus 2i plus the 1 plus 2i.
I think I'll just stick the foil.
Okay? So, he never had the FOIL. That was kind of cool. And you know what? You may see this and say, that makes total sense. So, you might do it that way. But, you may like that way better, and that's okay too. Alright, I just thought, that's pretty cool that, we'll see if anyone in 6th period picks up on that. But, I thought that was really neat, so, I never thought of that until, it was, Yutong Wang. She came up with that in 3rd period, so. Yutong and Maxime, and we'll see if anyone in 6th period comes up with that too. So. Alright, but hey, this is what's really cool about math, is that there's almost always more than one way to do something. Okay? So, that's one of the things I really enjoy about math.
No.
Alright, do you guys know the 24 game?
Yeah.
Yeah.
2048?
We need to make 20.
28.
No.
I just put this.
Oh. All day.
Wait,
I
2048.
used to try to see like how many different ways I could solve
Except
the
that
same
they
card.
merged everyone, so they all get
And that's what was pretty cool, you could solve the same card like 8 different ways a lot of times.
I don't know what 24 is.
I don't know how easy it is.
What is it? We should play
So you were already.
Yeah, play it. Well,
Now,
I just don't know what it is.
you take the 4 numbers on the card and you have to make 24 using addition, subtraction,
Sometimes 2
multiplication,
plus
division.
2 plus 1. 24.
Yeah.
2 times 7
Yeah.
times
7 times 2 plus 2.
Shut up.
7.
Wait, what number again did you guys?
Well, 24. Like here you do 2 plus 2 is 4, 7 minus 1 is 6, times 4 is 24. Or you do,
Times together.
or you do some other stuff too, but anyways.
So like 4
But anyways, the cool thing is that you could do the same thing a lot of different ways. Alright. Anyways. Now, we're gonna divide, so don't really need this. We're gonna divide complex numbers, but before we do, let's just really quickly review. If I had, say, 2 over radical 3, how would I rationalize that denominator?
Multiply by
Multiply by
radical.
Yeah, multiply by radical 3 over radical 3. You get 2 radical 3 over 3, and we're good, right? If you had 2 over 3i, what would you do?
Negative 3i, right? No.
I
I
times
over
I.
You could just use I over I, because that'll make this an I squared, so that's negative 3 on the bottom, and a 2i in the numerator. Okay? Now, the problem is, when we're dividing by a complex number, if I were to multiply this by I over I, now the 4 has an I, and I'd have plus 2. And if I tried it again, I would just switch back to this term, and we could keep passing it back and forth, forever.
4 plus 2i.
4 plus 2i.
Okay, good. And does anyone remember what that's called? What's that, Derek? Good. The complex conjugate. All right. The complex
Yeah.
conjugate. Now, the complex conjugate, we're talking about the conjugate of the denominator, okay? So the 2 plus 3i is still going to be here. But someone explain what a conjugate is.
It's like kind of like reciprocal. So like you multiply it by -1. Like you multiply 4 minus 2i times -1.
You switch the same.
Not quite. You can't just multiply by -1.
It's similar like we did before.
It takes
That's
out
Actually, it is like on the last problem.
so like you just like it takes out the middle term, so you'll just see you'll just see 14.
Okay, you're right. The whole point of using the complex conjugate is that when you FOIL it together, when you multiply together, the outer and inner terms in your FOILing will cancel out. And that's the term that you're going to get the i's from when you multiply. Okay? If you remember back here, the i's came from when we multiplied the outers and the inners. Alright? We want those to cancel out. What is the conjugate of 4 minus 2i?
4 plus 2.
Okay, good. It's 4 plus 2i. The first term has to stay the same. Okay? You can't make both of these opposites. The first term stays the same, and the last term changes its sign. Okay? So we'd have 4 plus 2i, and the reason why we're going to do that is that the top will go ahead and FOIL, so we have 8 plus 4i plus 12i plus 6i squared. The denominator, however, we have 16 plus 8i minus 8i minus 4i squared. Okay? The whole point of doing that was so that these cancel out to 0. And in our denominator, we will have a real number. Okay? Because we have 16 plus 4. So our denominator is now just 20.
2i.
Okay? In the numerator, we have 8 minus 6 is 2. 4i plus 12i is a plus 16i.
You factor the 2 or
And then, yes, you can factor and reduce this. Just do be careful that you cancel out a 2 from both terms in our numerator. So we would have 1 plus 8i over 10. Okay? Yes? Yeah. Alright? Is there any part of that we don't understand? Anything?
That would be
Okay. So, now this comes into play. We could be adding, things, fractions that have complex denominators, and you're going to get a common denominator, and then at the end you will need to rationalize that denominator. Or if you wanted, you could rationalize them at the beginning, and then when you're getting a common denominator, you're just dealing with real numbers. Okay? For example, when I go to do this problem here, I could get a common denominator first, add them, and then rationalize the denominator, or I could rationalize each of these denominators first, and then add the two fractions together. Okay? Same thing with the one down there, which we'll work on. Okay? So, let's go ahead and try some. Does anyone want to take a stab at any of these? We'll start with this one. 5i over 2 plus 3i quantity squared. Anyone want to do it for us? You want to do it? Okay.
If we get it wrong, that'd be embarrassing.
Yeah.
It
That
wouldn't
won't
be
be
that
embarrassing.
embarrassing. We're here for you.
Yeah, it would be really embarrassing.
It's embarrassing, like, if the walk around being crystal.
Is that embarrassing?
It's just unfortunate.
Okay, somebody, why did she do that? You can keep going.
Oh, okay.
To expand.
It's gonna go over there, so.
Okay, we're gonna expand the polynomial, so go to the square.
And then,
I know math terms.
yeah.
Okay.
This is a long problem.
Wait till we get to calculus next year,
Hold on.
then you'll have more problems.
Hold on. Like, what's the longest problem you ever done? Like 20 minutes or something?
Would the negative 5 stay the same, because you're just changing the center?
Yes, it would.
Yeah.
The negative 5 would just change this, or just stay the same. Good.
It's gonna take 4 or 5 minutes.
Alright, so you see now she's using the complex conjugate of that negative 5 plus 12i. Negative 5 minus 12i. If she had wanted to, she could have seen that denominator as 12i minus 5, and then the conjugate would have been 12i plus 5.
But how'd you get negative 5?
Because you have 4
Am I doing it right?
plus 9i
Okay.
squared, so 4 minus 9.
Oh, margins. One
How much is it?
144 plus 6. Mental math is not And I feel like, oh no, I can't divide by 2 because of the 25. Oops.
I did my research that too.
Is that right?
Alright, good, excellent. Alright, you guys see what's going on here? We FOIL out the denominator. We get it down to just a complex denominator. Then we use our complex conjugate.
Can't see the answer.
The answer is 60 minus 25i all over 169. Move this over a little
Wait,
bit.
can you not stop?
Just because I
Sorry.
knew that you would laugh.
Move it up a little bit. Okay?
I was laughing at you.
I don't even think I should rewrite that. So.
Alright, does that make sense?
Yeah.
So it's not too hard, but there's a lot going on here, right? We have to be careful.
Math is dangerous.
Math is dangerous.
I prefer it over reading though.
In the wrong hands.
I'm hilarious.
So.
Calm.
Alright, good. Good.
Yeah. Yes.
Throw that one down there. Love how it actually bounces.
So now we're doing the 2i over 2 plus I?
Alright, yeah, let's try the 2i over 2 plus I plus 5 over 2 minus I. Someone want to try this one? Alright, Alex.
Alex.
And you're welcome to explain too. I've been commenting, but you can explain too.
Explain. That's not my thing. Pressure.
Did you do the complex conjugate for both of these? Or did you do two?
You can.
It's not.
Is that not preferable?
It honestly, with this one, it makes no difference.
Doing this twice for both of them.
Okay. So Alex is recognizing what his common denominator is going to be, which actually happens to be, to get the common denominator on this one, you're actually multiplying by the complex conjugate. So this one's kind of nice. It's going to rationalize itself as you get the common denominator.
Then you have to multiply the 2I by 2 minus I and the 5 by 2.
Oh.
Because we're multiplying by 1, right? Okay. But you're right, the denominator is 5. We just need to make sure that we're multiplying by forms of 1. Okay.
So confused.
Now why do you have a 2 plus I there?
I have no idea what
Yeah, me either.
What's he at?
I use
Wouldn't you just?
Oh.
Yep. 12 plus 9i. Yep.
It's the pressure, guys.
I haven't
Can
thought
you add?
that far
Could you
ahead
add
yet.
2i plus 5?
Okay. Hey, someone explain while he keeps working, why did that have to be a 2 minus I?
I know what he was doing.
Nico?
So you have the denominator for the first term is 2 plus y, and for you, and you need to multiply times 2 minus y, so then you get rid of the y, and then you only get a y squared that you transform into a minus 1. Yeah, I squared that thing. And then you transform into negative 1.
Okay, so since you did that in the denominator, you have to multiply the numerator by a 2 minus I as well. Yeah, this actually ended up working out pretty nicely.
What happens to
So-
5?
Yeah, so what's the, so can't you just do
5.
2i plus 5 over 5, and then, so just 2i over, just 2i? Wouldn't it just be 2i? Because like if your common denominator is 5, then you add 2i plus 5, because you can like add it. And then if it's 2i plus 5 over 5, 5's cancel.
Well, you can't because, hang on,
I have no idea what he's doing.
you can't because you're like ignoring the common denominator. You're actually doing what he started to do first,
I got something different. Can you check?
okay?
Did you
It'll be clear. He just arranged his work a little bit differently, and that's okay.
Yeah, guys, equality.
There's no.
12 plus 9i.
Also wrong your numbers.
Okay.
Does anyone have something different from this?
I just have no idea what you did.
Okay.
Yeah, something different.
Then stop complaining if you got the same thing.
It's 12.
All right. Well, let's look at
divided by 5.
the only thing
I
here.
didn't do it because I
If you
never
look-
changed it.
Make sure you distribute.
Buddy.
Okay. Distribute the 5 to both
Part of the
parts.
same thing as you.
So plus 5i, and that'll
Because you
make
got
that
10
a.
plus 9i plus 2.
Yeah,
Yeah.
divided by
And then
Yeah,
that would be 9i. There we go. Alright, so there's our correct answer. Let's take a look.
No idea what he just did.
Some of you, a lot of you didn't follow exactly the order he was doing things, so let's just look at it, because this is correct. Alright, first of all, he recognized his denominator was going to be 2 plus 1 times, or 2 plus I times 2 minus I. So he figured out what that was going to be first. Okay? It was going to equal 5. So that's why he has it as his denominator right there. Okay? Then he figured out his numerators separately. So he took this 2i, and since there was already a 2 plus I, he had to multiply it by a 2 minus I. Okay? To get the common denominator. And if you do that in the denominator, you have to multiply by the same thing in the numerator. Because remember, this is just 1. Okay? We're just multiplying by a form of 1. So this work right here is him figuring out what his first numerator is by multiplying 2i by 2 minus I.
So pretty much you do like each one individually and you just add them together?
You can.
Okay.
You can. I personally wouldn't have shown my work this way, but that's fine. As long as I can understand what you're doing. Okay? So here's our first numerator, and that's right here. Okay? Then the second numerator, with this 5, this fraction already had a 2 minus I, so he had to multiply by 2 plus I. 2 plus I, and that's what he was doing right over here. 5 times 2 plus I is 10 plus 5i, and that's what ended up there. Okay, so here's our first numerator, here's our second numerator. It's all over 5 because we have a common denominator now, and we can combine like terms. Okay? Thank you. Alright. So, he showed his work a little bit different, maybe than you would have, but it's all there, okay? All I would ask is, notice how he labeled some stuff? That's our denominator, that's the first one, okay? If you have things and you think things might be a little challenging to find, label them, okay? For example, on the quiz, some of you had a hard time finding what your zeros were. I mean, I saw them on the graph, but I couldn't find where in your work it was. Or when you were finding your max and min points, I had a hard time finding where those max or min points were. Or at least where the work was. Okay? So. Alright. For the last one. This one isn't quite as nice. What's our common denominator going to be, though?
Negative 1? No.
4i plus 1.
Okay. And if you don't multiply it together yet, you're going to have I times 4 minus I, right? That's going to be your common denominator. To get that, though, I have to multiply this by a 4 minus I, so that this is a form of 1, right? That's 1 I'm multiplying by. Well, this one I need to multiply by an I, so I need to multiply the numerator by an I as well, because I over I is 1. So now we have to simplify. By the way, personally, this is the way I would show my work. Any way is fine as long as it's clear. Okay? So I FOIL the numerator. I get 4 plus 4i minus I squared. And then I have this minus 3i as well. Okay? That's all over 4i minus I squared, which happens to be 4i plus 1. Okay? Yes.
There's an easier way to do that. Because if you do for one, I'll do it after. Can I show me how I do it after?
Okay. Now as you look at this, we simplify the numerator and denominator, and then we're going to rationalize our denominator if we have to. Okay? I have a 4i minus a negative 1, so 4i plus 1. Notice here, 4i minus I is 3i, minus 3i is 0, so there are no i's left. But 4 minus a negative 1 is 5 in my numerator. Now, what am I going to multiply by to rationalize our denominator?
4i minus 1.
There you go, 4i minus 1. Okay. So, our final answer, 20i minus 5 over, what do we get for our denominator?
Four,
Negative 17. No.
no, four,
Close.
4,
You can do it.
Bring forward, no.
4i squared. Wait, I'm sorry, you were right.
Yeah.
Right?
Yeah, sorry, I had the I on the wrong term. 4i squared, or I'm sorry, 16i squared is a negative 16 minus 1, negative 17. Okay? And you can stop right there. You don't need to try to simplify any further. The one note I will make, if they asked you to put this in standard form, the only thing you would need to do is we have a negative, listen real quick, negative 5 over negative 17 would be 5/17, and then 20i over negative 17, that would be a minus 20i over 17. A plus bi. That would be standard form, technically.
So that's
Okay.
the right answer, or that's not the right?
This is correct, this is standard form. So, alright, there's some problems on homework blog.
Yeah. Like I wasn't there, because I didn't see the movie, but I haven't read the book. I think we
So, see ya. Bye.
要这样，这个流程要在这，这个流程。